So today we are going to start principles of heat flow in fluids. Principles of heat flow in fluids. In unit 1 we have discussed conduction. Conduction is first kind of mechanism by which heat flows in solids. Now in fluids, because in chemical industries we deal with solids and fluids. Fluids includes liquids and also gases. So both fluids, both liquids and gases, heat transfer takes place mostly by convection. This is the main type of mechanism in chemical industries, because in chemical industries you can see many fluids flows through pipes always. Then heating of fluids is required, cooling of fluids is required, and condensing of vapors is required, and boiling of the liquids is required. Because all these aspects, convection mechanism and heat transfers, what are the principles of heat transfer in fluids, we are going to discuss. How to calculate rate of heat transfer Q in case of fluids, we are going to calculate. In case of solids, we have discussed very clearly how to calculate Q for 3 different shades. In the same way now, in case of liquids, we want to discuss now how to calculate Q. That is a principle of heat flow in fluids. To discuss that, in the beginning we want to discuss an equipment, that is typical heat exchange equipment. Heat exchange equipment, an equipment which exchanges heat, exchanges between what and what. It can be between vapor and liquid, or it can be between liquid and liquid, or it can be between vapor and vapor. Anyway, that is the exchange of heat. Now in this diagram we want to discuss particularly condenser. With help of this diagram, just some basic principles, how heat transfer takes place, how heat exchange takes place, we can discuss using this condenser diagram. So in this condenser diagram, here this consists of a shell. This is a shell. This consists of a shell and a bundle of tubes. Here you can see, you can even count here, first tube, second tube, third tube, like that. A bundle of tubes are arranged here. These are tubes. These are tubes. A bundle of tubes are arranged in a shell. That is the first point here. Next, how to arrange this bundle of tubes? Simply, they can't stand themselves inside the shell. So, to keep the tubes in their positions, we use here tube sheets. These are this one and this one. 2 tube sheets we use. 2 tube sheets we use. One at the here one end and the other at the other end. With help of these 2 tube sheets, we fix these tubes in their places. That means here this tube sheet is perforated with holes here. The diameter of this opening should be equal to the outer dia of the tube. The diameter of the opening, each opening in the tube must be equal to the outer dia of the tube, so that this tube correctly fits into this. Like that, these tubes are arranged with help of tube sheets. And here this is one chamber here, and this is one chamber. 2 chambers here, at one end and at the other end. Now if you observe this, and in this again shell thickness, this shell thickness is more compared to the tube wall thickness. Why? Actually, in heat exchangers, pressure is very important. Heat exchangers are here, it is condenser. In this condenser also, inside pressure is important. Usually the pressure will be high only. So, this shell should be able to withstand that much pressure. So, shell thickness is more compared to the tube's thickness. And another point, here you can see one opening here. This opening, vapor. This is condenser which is used to condense vapor. We are going to convert vapor to liquid with the phase change here. This is phase change is there with phase change. Heat transfer with phase change. This diagram is for condensing vapor. Condensing vapor. So here vapor is introduced here at the inlet, vapor inlet, this one. Now after vapor enters here, we will see. Next we will discuss. Now you can see another way here. This one here. This is what? Liquid inlet. This is liquid inlet. That means where the cold fluid enters like this, and here cold fluid, that is cold liquid, after getting heated will be leaving from this. Okay, so now how the heat transfer takes place we will see. Once cold liquid enters here, it fills up this, it fills up the entire chamber. Then it enters all these tubes like this, and then flows to the other end of the exchanger. Then comes out like this. Then after this it will be leaving like this from the top. So this is one fluid. Any heat exchange equipment, we can see two fluids. One fluid is here cold fluid which is going to get heated, and another fluid is the actual vapor which is to be converted into liquid. That vapor enters here. After vapor enters here, then it fills up the entire shell. Where it comes into contact with the tube surface. These are the tubes here. So it comes into contact everywhere throughout the surface of the tubes. Over all the tubes, this vapor comes into contact. And inside the tube, what is flowing? Cold liquid is flowing inside the tubes. So when this surface is maintained at lower temperature, so when the vapor comes into contact with this cold surface, it loses its latent heat. Vapor loses its latent heat. After losing latent heat, it will condense. So that condensate that is in the liquid form, now it falls into this here. This is being removed. Okay, this is the concept here. Vapor enters here, cold fluid is flowing through the inside of the tubes. Then when vapor comes into contact here with the cold surface, it will lose its latent heat and will be converted into liquid, that is condensate. Finally all the condensate comes out from the bottom of the shell like this. So this is vapor inlet, condensate outlet. This is one fluid. And the second fluid, cold fluid, fluid inlet and cold fluid outlet. Okay. So here usually we denote by TCA, here cold fluid, and here cold fluid. C indicates cold, small a indicates inlet. So cold fluid inlet temperature, small v indicates outlet temperature. So cold fluid outlet temperature, that is TCB. Then what about TH? You may think here TH here, THB, but no, because we are making two assumptions in this case condenser. If it is a heat exchanger, you will have THA and THB. But here vapor is, assume that vapor is entering at its condensing temperature. Vapor is entering at its condensing temperature. At its condensing temperature. And this is one assumption. Another assumption is here condensation is taking place at its condensing temperature. Condensation is taking place at its condensing temperature. Condensing temperature is denoted by Tc. Okay, so that means vapor is entering at its condensing temperature. That means, for example, steam you take, steam is entering at 100, condensing at 100. There is no superheat in the steam, and we are also neglecting subcooling of the condensate. That means after it only loses its latent heat, then it will be converted to liquid. The liquid also leaves at TH. Vapor enters at TH, condensate also leaves at TH. Then why the temperature is not changing? Because it is losing only its latent heat, but not sensible heat. That is why. And one more important point in this is we need to maintain pressure constant inside this equipment, because condensing temperature depends on pressure. Condensing temperature depends on pressure. Okay. So if pressure is maintained constant inside, then condensate temperature will also be maintained constant. So like this. Now after this we will discuss how to draw the curves and all that. So here, now you see the diagram. This is distance from cold fluid cold fluid inlet, and this is temperature. Okay, this is distance from cold fluid inlet and this is temperature. Now for the condenser, if you want to draw the diagram here, then you have, just now I have discussed, we have two fluids. One is hot fluid. Here hot fluid is vapor in this condenser. One is vapor, hot fluid. What is the entering temperature and leaving temperature? THA equal to THB equal to TH. This is hot fluid. So how you will get distance from cold fluid inlet? Means what is this? Along the length of the condenser. Means as the length of the condenser is increasing, is it like a tube length is increasing? It is like tube length is increasing. With respect to tube length, how temperature of hot fluid will change? That's what we want to write here. It is not changing. Vapor temperature is not changing and we are assuming that entering at its condensing temperature TH and also leaving at its condensing temperature TH. It's not changing. So you will get a horizontal line, hot fluid. And we have another fluid, that is second fluid. So that is cold fluid. So assume that cold fluid is entering here, TCA. Entering temperature of cold fluid is equal to TCA. Entering temperature of cold fluid equal to TCA. Let it be this entering temperature. Then leaving temperature of cold fluid equal to TCB. Cold fluid temperature will increase because it's taking latent heat from hot vapor. So its temperature will go on increase. This is TCB. Okay. So this is how we are showing how temperature is changing with respect to the distance from cold fluid inlet. Means with respect to tube length, you can say. With respect to tube length. When length of the tubes is increasing, when length of the condenser is increasing, how temperatures of both the fluids are changing. Here hot fluid is remaining constant and cold fluid is increasing from TCA to TCB. So now you can see this is the difference here, delta T. So what is delta T? Delta T is called point temperature difference. Delta T is called point temperature difference. So this means here the temperature is TH. Here somewhere some temperature in between TCA and TCB. That is called delta T. So what do you say? As the length of the tube is increasing, what about delta T? As the length of the tube is increasing, delta T will increase or decrease? Delta T will decrease because here temperature difference is more, here temperature difference is less. So this is how delta T will be changing. Now at this entrance here, this is called delta T1 and here this is delta T2. So what is delta T1? Delta T1 is point temperature difference at entrance. Point temperature difference at entrance. Delta 2 is equal to point temperature difference at exit. Okay. So here delta T1, here delta T2. So delta T1 is fixed, delta T2 is also fixed. That means delta T1 and delta T2, they are constant value. Wait one. Constant values. I told you in the beginning. I am recording it separately. Okay. So delta T1 equal to delta T2 equal to constant values. So these constant values, these are called terminal point temperature differences. These are called terminal point temperature differences. Okay. So delta T1 is constant, delta T2 is constant, but delta T varies between delta T1 and delta T2. And this delta T1 and delta T2 are called approaches. These are called approaches. There are two terms we are going to learn in this. one is approach and the other is range. Delta T1 and delta T2 are called approaches. And another term we are going to learn is range. Range means what it is? Range means, suppose if you go to shop, no? Suppose if I go to shop to purchase the sarees, the shopkeeper will ask me, what range you want, madam? They'll ask. So I may say some 5,000 to 10,000 or and like that. So the initial value, minimum value and maximum value we should tell. That is the meaning of range. So here range means here TCA is the minimum value and TCB is the maximum value. So this is the range of cold fluid. Okay, then range of cold fluid here, that is TCA to TCB is the range of cold fluid. What about range of hot fluid here? 0, because hot fluid is not changing its temperature. That means in condenser you will have only one range. But in case of heat exchanger, next lecture we will also discuss about this range again. Two range of hot fluid THA to THB, range of cold fluid TCA to TCB. In case of condenser we will have only one range, that is TCA to TCB. So approaches are what? Delta T1 here and here delta T2. Thank you.